Imagine a time, far, far back in Earth's history, when the moon didn't just hang in the sky, but loomed enormous, a breathtaking spectacle, 10, even 15 times larger than it appears today. Picture the sheer scale of it, dominating the heavens. The nights weren't just dark with a faint glow. They were bathed in brilliant silvery light, almost like a perpetual twilight, casting sharp, stark shadows across a wild young Earth, a landscape still raw and untamed. Imagine the shadows of early life forms stretching long and distorted under that intense lunar glow. This incredible closeness wasn't a coincidence. It was the result of a violent birth, a cataclysmic event that shaped our world. A Mars-sized object, often referred to as Theia, collided with Earth in a colossal impact, a collision that would forever alter the course of our planet's history. The force of the impact blasted vast amounts of debris, molten rock and dust, into orbit around the newly formed Earth. Over time, gravity, the ultimate sculptor, sculpted this chaotic ring of debris into the celestial body we know as our moon, a process of accretion and gravitational assembly. The moon, in essence, was born from Earth's own mantle, a piece of our planet ejected into space and reborn as a satellite. The newborn moon, still hot and molten, orbited incredibly close to Earth, a mere fraction of the distance it is today. This proximity forged a powerful gravitational bond with Earth, a connection that dictated the rhythm of the early planet. The young Earth, still reeling from the impact, spun rapidly on its axis, a dizzying pace compared to today. As a result of this rapid spin, days lasted just 5 or 6 hours, a fleeting moment between sunrises. The moon's immense pull, due to its close proximity, raised colossal tides on Earth, far beyond anything we experience today. These weren't gentle waves lapping at the shore. They were monstrous walls of water, hundreds of meters high, surging across the landscape. These extreme tides relentlessly reshaped the planet's surface, carving out coastlines and sculpting the land with unimaginable force. This was a world of extreme forces, a planet forged in fire and shaped by the relentless pull of its giant companion. It was a cosmic dance of power and intimacy, a dynamic relationship between two celestial bodies locked in a gravitational embrace. But over vast stretches of time, the moon began to drift away, slowly but surely increasing the distance between itself and Earth. The story of its retreat is not one of random chance, but is precisely written in the immutable laws of physics, the fundamental rules that govern the universe. It's a tale of gravity, the force that binds, energy, the currency of the cosmos, and the subtle, intricate interplay between planet and satellite, a delicate balance of forces acting across immense distances. This gradual process has unfolded for billions of years, a testament to the immense timescales over which the universe operates. And remarkably, this lunar recession continues even now, a subtle but measurable phenomenon. The moon is leaving us, slowly but inexorably, not in haste or anger, but with quiet, inexorable grace, a cosmic ballet performed on the grandest stage. It's a cosmic farewell that will outlast the history of life on Earth, a separation that will continue long after we are gone. So how did we get from that giant looming companion, a celestial behemoth dominating the sky, to the distant pearl, that serene and smaller orb we see gracing the night sky today? The answer lies in the intricate physics of tides and motion, the fundamental forces that govern the interaction between Earth and its moon. Let's delve into the past and explore how this slow, steady separation began, unraveling the mysteries of our planet's ancient relationship with its celestial partner. The moon's journey away from Earth is a captivating story of energy transfer, gravitational interactions, and the relentless march of time. And it's a story that's still unfolding, right above our heads every single night. To understand the intricate dance of the moon's journey away from us, a celestial ballet performed over eons, we must first understand gravity, the invisible force that governs the cosmos. It's the universal glue that binds everything together. Gravity isn't just what keeps us grounded, preventing us from floating off into the vast emptiness of space. It's the fundamental force that binds planets in their orbits around stars, dictating their paths and preventing them from drifting away. It holds stars together in galaxies and moons in orbit around planets, creating the beautiful cosmic structures we observe. The moon, though significantly smaller than Earth, possessing only a fraction of our planet's mass, exerts a surprisingly powerful gravitational pull, a testament to the nature of gravity itself. It tugs on everything here on Earth: rock, air, the very ground beneath our feet, and especially the vast interconnected oceans that cover most of our planet's surface. The moon's gravity pulls more strongly on the side of Earth that is closest to it, creating a bulge of water, and less on the far side, where the gravitational influence is weaker due to the increased distance. This difference in gravitational force creates what we call tidal forces, a cosmic tug-of-war, a gentle but persistent pull that subtly stretches our planet along the Earth-Moon axis. The result of this celestial game of tug-of-war? Two significant bulges of water, one directly facing the moon, drawn towards it by the force of gravity, and another on the exact opposite side of the Earth, a consequence of inertia and the Earth's rotation. These bulges are what we experience as the high tides, the ocean's rhythmic rise and fall, a direct response to the moon's constant, unwavering embrace. In a way, Earth behaves like a slightly squishy ball, subtly flexing and deforming under the continuous gravitational pull of the moon. The land itself shifts, rising and falling by small but measurable centimeters. But the oceans, being fluid and more easily influenced, move much more dramatically, responding to the lunar pull. This interaction creates the familiar and predictable rhythm of the tides, a cycle that has shaped coastlines and influenced marine life for billions of years. This constant stretching and flexing of our planet is the first key to understanding the moon's slow but inevitable retreat from Earth. The tides are far more than just a daily phenomenon we observe at the beach. They are, in fact, the engine, the driving force, slowly but surely pushing the moon away from us, millimeter by millimeter, year after year. Every high tide, every surge of water towards the shore, represents a tiny but significant transfer of energy from the Earth to the moon. The moon's gravity not only shapes our world in profound ways, influencing our oceans and even the land itself, but it also, paradoxically, sets the stage for its own slow and gradual escape from Earth's gravitational embrace. The process is incredibly subtle, almost imperceptible on a human timescale, but it is relentless, driven by the fundamental laws of physics. The moon's gravitational embrace, while seemingly permanent, is actually the beginning of a much larger and more complex story, a story of gradual separation and cosmic evolution. Let's delve deeper and see how Earth's spin, its daily rotation, further complicates and ultimately drives this fascinating process. Earth isn't just being pulled by the moon, it's spinning rapidly like a top. A day lasts 24 hours, but the moon takes 27 days to orbit us. This speed difference is crucial. Earth's spin drags the tidal bulges ahead of the moon's position. If Earth didn't rotate, the bulges would align perfectly with the moon. But our fast spin pulls them forward, creating a slight offset. Imagine running with a bucket of water. The splash moves ahead of you. The same happens with Earth's oceans. This offset is tiny, but over billions of years its effects are immense. The bulge's position ahead of the moon is the key to the moon's outward journey. Earth's rapid spin and the moon's gravity are locked in a subtle struggle. This is how a simple tidal bulge becomes a cosmic engine. The tidal bulge, dragged ahead of the moon, has mass and gravity. Its forward pull gives the moon a tiny, constant nudge in its orbit. Like pushing a swing at just the right moment, this adds energy to the moon's path. The result? The moon speeds up slightly and moves into a higher, more distant orbit. In orbital mechanics, more energy means a larger orbit, even if the moon moves slower overall. Each high tide, each tiny push, adds up over billions of years. The moon's outward spiral is almost imperceptible, but relentless. This process has moved the moon from a close companion to its current distant home. The gentle push of the tides is the engine of the moon's escape. It's a process that never stops. The story of the moon's retreat is written in every wave. If the moon gains energy, Earth must lose it. The source? Earth's rotation. As the tidal bulges pull the moon forward, they also drag against Earth, slowing its spin. It's a cosmic transaction. Earth's rotational energy is transferred to the moon's orbit. The result? Earth's days grow longer, the moon moves farther away. This exchange is governed by the conservation of angular momentum. In the early days, Earth spun fast and the moon orbited close. Now Earth spins slower and the moon is farther out. This process, tidal acceleration, shapes the length of our day and the moon's distance. It's a silent, powerful exchange that has lasted for billions of years. The Earth-Moon system is locked in a dance of give and take, and the rhythm is set by gravity and time. The moon's escape means longer days on Earth. As tides slow our planet's spin, each day grows a tiny bit longer. The change is slow but measurable. Lasers bounced off Apollo reflectors show the moon recedes 3.8 centimeters per year, the speed of growing fingernails. Over millions of years, this adds up. Days lengthen, the moon drifts away. Once, days lasted just hours. Now, they're 24 hours long. The process isn't perfectly steady. Continents, oceans, and ice ages all play a role. But the trend is clear. Earth's spin slows. The moon retreats. We live in a fleeting moment of this long transformation. How do we know days were shorter in the past? The answer is written in stone and in ancient life. Fossil corals, like trees, record daily and yearly growth bands. Devonian corals show a year once had about 400 days, meaning shorter days. Sedimentary rocks called tidalites preserve ancient tidal rhythms, confirming faster spins and closer moons. The evidence is clear. Earth spun faster, days were shorter, and the moon was nearer. Science isn't just theory, it's confirmed by the rocks beneath our feet. The fossil record and physics tell the same story. The echoes of a faster Earth are preserved in stone. Our planet's diary is open for those who know how to read it. What does the future hold? The moon will keep drifting away, and Earth's days will keep growing longer. In the far future, Earth could become tidally locked to the moon, one side always facing its companion. A day would last as long as a month, over 1,000 hours. Tides would become gentle ripples, the moon a faint, distant light. But this future is billions of years away. Long before then, the sun will become a red giant, likely ending this cosmic dance. The fate of our star will overshadow the slow evolution of the Earth-Moon system. The moon's journey will be interrupted by the drama of the dying sun. Our story is just one chapter in a much larger cosmic tale. The moon is slowly, almost imperceptibly, leaving us, drifting away on a cosmic timescale. It's a departure measured not in years but in eons. But this isn't a story of loss, of something precious being taken from us. It's not a cause for sadness or despair. It's a story of connection. A deep, fundamental link forged over billions of years, a bond that continues to shape our world. It's a story of tides, those rhythmic pulses of the ocean that some believe may have sparked the very beginnings of life on Earth, the moon's gravitational pull orchestrating the dance of the seas. And it's a story of a stabilizing force, a celestial anchor that has helped to shape our planet's climate, keeping it within a habitable range for life to flourish. A silent guardian, influencing weather patterns and temperature fluctuations. We are, in a very real sense, children of the Earth-Moon system. Our origins are intertwined, our destinies linked. When you look up at the moon on a clear night, you see more than just a distant rock. You see a partner, a stabilizer, a constant presence in the sky. A silent witness to our planet's long and turbulent history, observing the rise and fall of continents, the evolution of life, and the unfolding drama of our world. The moon's slow, almost imperceptible retreat reminds us that the universe is in a state of perpetual change, a dynamic and ever-evolving tapestry of cosmic events. Nothing remains static. Everything is in motion. For all of recorded human history, and likely long before and for countless generations yet to come, stretching far into the future, the moon will remain, in our sky, our constant companion. It will continue to govern the tides, shaping coastlines and influencing marine ecosystems. It will light our nights, casting its silvery glow across the landscape, transforming the familiar into something magical. And it will continue to inspire wonder, sparking curiosity and fueling our dreams of exploration. Its journey is a testament to the fundamental forces of gravity and the relentless march of time. So the next time you gaze up at the moon, hanging in the velvet sky, remember its immense journey through space and time, a voyage that has shaped our world in profound ways. Think of the energy it has borrowed from Earth over billions of years, a subtle exchange that continues to this day, and the days it has lengthened, slowing the Earth's rotation and gradually extending the hours of daylight. The cosmos is not a distant alien realm. We are an integral part of its unfolding story, connected to the universe in ways we are only beginning to understand. The moon's slow retreat is simply a continuation of the grand cosmic ballet, a dance of celestial bodies orchestrated by gravity and time. And we are privileged in this fleeting moment of cosmic time to witness this extraordinary spectacle.